So our goal for today is we're gonna dip our toe into the magical world of factoring. That's mostly what we're going to be doing in this unit, although there's a couple other small topics that we'll be addressing. And what you're going to find today that is factoring is the same thing as some stuff that we've already done, just in reverse. Okay, so to start off, I'm going to ask you to do a problem that you guys are all probably, hopefully, super familiar with. Could you guys go ahead and multiply this 4 times this 3x plus 4? I've already drawn the arrows over top there. We're just going to multiply and multiply. We're distributing. You guys have done this maybe not 1,000,000 times, but probably 100 times at this point if you've been doing your assignments. So multiply that 4, get me an answer and write it, put an equal sign, put it right off to the side here. You guys feeling confident with this? This is nothing new, right? Here, I'll help you out if you need a hint. I'll do the first term for you. 4 times 3x is 12x. And there's a plus there, and then you just need to do the 4 times the 4. We all got an answer? 12x plus 16. That's the answer. That's the answer to a distribution problem. A factoring problem is just the reverse. So in a factoring problem, we're going to start off with the 12x plus 16, and you're going to factor out what's called a GCF, and I want you to write down what that stands for. It stands for greatest common factor. All right, in a distribution problem, that is this 4 here. In a factoring problem, it's also going to be a 4. And inside here, we would have 3x plus 4. So it's the same thing that we've done, it's just in reverse. It's kind of like I'm giving you the answer to a distribution problem, and you have to write the question. That's it. That's it. So for each of these problems, I'm going to show you what it's going to look like. We're going to write a problem. We're going to write an answer that's going to say some number or some term in front, and then a parentheses. And there are 2 terms here, so I know I'm going to have 2 terms inside of my parentheses. There's a plus here, so I know this is going to be a plus. And I just have to figure out what goes in those 3 spots. That's it. And then I can check when I get finished by distributing, and if I distribute this and I get this as my answer, then I've done it correctly. All right, so let me walk you through this. So the tricky part's just figuring out what goes inside, and really the main piece of work is to figure out what goes in front. We want the GCF, okay? So I'm going to walk you through, and there's sort of a long way and a short way to do this. I'm going to walk you through the long way, and you guys you're going to discover, many of you are going to discover some shortcuts today. So I'm going to look at this problem, and I'm going to look at this 5 and this 2, and I'm going to write factor pairs for 5 and 2. So write me some factor pairs for 5. We'll start with 1. 1 times 5. Does 2 go into 5? No. Does 3 go into 5? No. Does 4 go into 5? No. 5 goes in, but it's a repeat, so that's it. That's our only factor pair. How about a factor pair for 2? 1 times 2. Anything else? No. All right, now we need to find the greatest common factor. I need to look at these 2 lists, and I need to find the biggest number that appears in both of those lists. What is the biggest number, actually the only number that appears in both of those lists? 1. So 1 is going to go into our GCF. Now it's not always going to be 1, but sometimes it will. Now, then we also have to look at the variables. Notice there are n's here and here. And the trick with your variables is you want to go with the smallest number of variables. As long as they're in all of the terms, there's n's in both of my terms here. You want to go with the smallest number of n's. What's the smallest number of n's? There's a single n here, so we're going to go with a single n in our GCF. Okay, so you go with the greatest common factor for the coefficients. We go with the smallest number of the variables. We got our GCF. Any questions so far? Now all we need to do is work backwards to figure out what's going to go inside that would give us these two things if we were to multiply it out. So let's think to ourselves, what do I need to put in this spot? It needs to multiply by 1n to get us 5n to the fourth. What multiplies by 1 to get us 5? 5. And what multiplies by n to get us n to the fourth? How many n's am I going to need in here so that when I multiply it by this n outside, I get 4 n's? I say I need 3. Right? If I multiply an n times 3 more n's, that would be 4 n's multiplied together. That would be n to the fourth. Agreed? All right, we got to figure out our last term here. This one needs to multiply by 1n to give us 2n. What multiplies by 1n to give us 2n? How about 2? 1n times 2 is 2n. And then I could double check, do the distribution. 1 times 5 is 5, n times n to the third is n to the fourth. Good. 1n times 2 is 2n, and we got it. There's our first problem. How you guys feeling? So far, so good? Let's try another one. All right, in this one, we are going to start by finding our GCF for 4 and 2. I'm going to write my factor pairs for 4. That's 1 times 4 and 2 times 2. Those are the only ways to get 4. And the only way to get 2 is 1 times 2. It's nice when the numbers are small because these factor pair lists are pretty short. What is the biggest number that appears in both of our lists this time around? 2 appears in both of our lists, and it's the biggest one. 1 is also in there, but 2 also is in there. So let's put a 2 out in front. I need an equal sign here. And then look at the variables. Do both of the terms have b's? Yes. Okay, so we're going to need some b's in here. How many should we have in here? Remember, we want to go with the lowest number of each variable. Just a single b, right? That's the lowest number of b's in our terms. All right, let's get a parentheses going here. And I know because there are 2 terms here that I'm going to have 2 terms inside. The signs are going to match the signs on the outside, so I'm going to put a negative here and a positive here. And then I just need to know what goes inside that would multiply to give us our original terms. So I'm thinking I need to multiply 2b times something to get negative 4b. What multiplies by 2b to get 4b? Just a 2, right? 2 times 2b would give us 4b. We've got the negative taken care of. All right, over here, what multiplies by 2b to get us 2b to the fourth? 1b to the third. B times 3 more b's gets us 4 b's. And that's it. That's it. Do you suppose we need to have this 1 here? Could we erase that 1? We could if we wanted to. Or we could leave it. Either way is fine. All right. Let's do another one. 36 and 81. So I'm going to write factor pairs here. Let's do some factor pairing. 36 and 81. 36. 1 times 36. 2 times, help me out here, 18. I'm pretty sure 3 goes into 36 also. 3 times 12. 4 times 9. 5 doesn't go into 36 because it doesn't end in a 5 or a 0. Does 6 go into 36? Oh yeah, 6 times 6, and then we got to repeat there, 6 times 6. Okay. So there's our list for 36. Let's do a list for 81. 1 times 81. 2 does not go into 81 because it's not even. I'm pretty sure 3 does, though. Someone help me out with, what's 81 divided by 3? 27. 4, no. 5, no. 6, I don't think so. 7, 8, 9 definitely does. 9 times 9. I think that's, well, and then we got a repeat, so we're done. That's weird. It's a bigger number, but it actually has less factor pairs. All right, look through our factor pairs and tell me what is the largest, what is the greatest common factor in those two lists? 9 appears in both, and 9's the biggest. All right, so let's get this thing set up. We know we're going to have a number out in front. We know we're going to have a parenthesis. We know we'll have two terms inside. And we'll go ahead and just transfer the negatives into here. Our GCF is going to have a 9. We decided that was our largest common factor. And then what's the largest number of k's that appears in both? So we're basically looking for the smallest number of k's. So you guys, the reason we go with the smallest is it's got to be the biggest number that appears in both. There is 1 k in both of these things. There are not 2 k's in both terms. The biggest number of k's that's in both is 1. So that's why we basically go for the smallest exponent. So 9k. Then we just got to figure out what's going to multiply inside to get us what we need. Now the nice thing about these factor pairs is if I'm trying to figure out what multiplies by 9 to get 36, it's right here on my list. It's 4. Right? 4 times 9 gets us the 36 we're looking for. So that's got to be a 4. Is it just a 4 or do we need some k's in there too? I'm trying to get k squared. I've only got 1 k multiplying on the outside. I think I'm going to need another k in here. That k times k will give us this k squared we need. All right, and then we need an 81. We got to multiply 9 times something to get 81. What multiplies by 9 to get 81? 9. Do I need any more k's in this term? I only need 1 k. I'm already getting that from the one that's multiplying on the outside, so that's enough. So that's going to be it. Try this next one on your own. Who's interested in a shortcut? Who are my shortcut enjoyers in here? Shortcut fans? If you know your mental math, you don't have to make these lists. Okay, some of you might have looked at these two numbers and said, ooh, 9 goes into both of those numbers. Then I wouldn't have had to make these lists. I would have been able to just write this 9 out here. But you got to know your mental math well enough to be able to kind of think through all the numbers that might go into them and pick the biggest one. Because you might have looked at these and said, oh, 3 goes into both of those, which is true, but there's something bigger. So if you can look at 36 and 63 and know what's the biggest number that goes into both of those, you don't have to make your lists. But if you don't know that, then go ahead and make your lists. Uh, 36. I'm thinking 9. Does 9 go into 63? Yeah, it does. So I'm thinking it's going to be 9 for my GCF. But if you're not sure, again, you can always make your list. You doing it? Are there going to be any ends in my GCF for this one? Tell me why there are no ends in my GCF this time around. Yeah, one of these terms does not have any ends in it. So in order for there to be ends in the GCF, all of your terms have to have ends. Since this one doesn't have an n, there are no n's in this. So your GCF is just 9. It is just 9. All of your n's are going to have to be inside of the parentheses. All right. How many people were able to get that answer on their own? If you're not quite there yet, that's okay. We've got some more practice coming up. I want to show you guys something really quick. A lot of times when you have two terms, these are called terms here, that are both negative, a lot of times we will use a different format of this answer. Let me show you a different format. Can you guys look up here and compare these two answers? And then I want you to convince yourself that both of them are correct. If you were to distribute here, you would still get a negative 36k squared, wouldn't you? And you would still get a negative 81. So I'm going to give you an assignment sheet. I'm going to show you answers on Friday. And some of the problems are going to look just like your answers, but all the signs will be flipped. Usually, if both of these are negative, when we do our GCF, we actually put the negative on the outside, so all this stuff in here becomes positive. Okay, but I need you to know that both of these are correct. So if the answer sheet said this, and your paper said this, I need you to be able to look and say, that's the same thing, this is just fine, okay? I would never count you off for using this answer instead of this on a test. Never, ever, ever. And I don't know any teacher that would, even at like Algebra 2 level, okay? Just a lot of times they will factor the negative out. You'll see why when you get into Algebra 2. We're going to do more stuff with this later on in Algebra 2, and we want this to be as positive as possible. It just makes life easier. Okay? All right, let's go on. The only thing that changes when we get more terms is that when we find our GCF, we've got to find things that are factors of all three. All right, so let's get this thing set up. We know we're going to have a GCF out in front of some parentheses. How many terms are going to be in the parentheses this time? 3 terms in here this time. And I'm just going to go ahead and copy my pluses in there. Let's see if we can do this shortcut way this time. I want you to look at these numbers, 18 and 24 and 6. What is the largest number that goes into 18 and 24 and 6? 6 goes into all of them, right? And there's nothing bigger than 6 that can go into 6, right? So I'd say our GCF is going to have a 6 in it. Now, I could have gone in here and did 1 times 18, 2 times 9, 3 times 6, 1 times 24, 2 times 12, 3 times 8, 4 times 6, 1 times 6, 2 times 3. I could have made all my lists and I would have found that also. 6 is the biggest number that's in all 3 of those lists. So if you're not super strong with your mental math skills, remember you can always fall back on these lists and they don't take that long to make. My next question though is there an n in this GCF? Do all 3 of the terms have n's? No, so there's no n in here. So that's it for my GCF. I just need to figure out what goes on the inside here. So 6 times something is 18. 6 times 3 is 18. And I'm going to need all of my n's inside because there's no n's to multiply on the outside. All right, here 6 times something is 24n. 6 times 4 will get me the 24, and then I need an n. And then this last one, I need to put something in here because I need to get 6. What do I multiply 6 by to get 6? 1. That 1 has to be there. Common mistake is that people will leave that 1 out. All right, go ahead and try the next one. I think a lot of us are going to be able to find a GCF here without doing lists. Let's see if we can jump straight to our answer. Were you guys able to find the GCF for 50 and 20 and 40? Did you get something different than I have up on the screen, I hope? Can I get you guys to look at what I got up on the screen really quickly? I made a mistake here, but I want to show you something through this mistake. Check my work there. If I were to multiply that 5, would I still get 50 and 20 and 80? Or sorry, 40? I would. So my answer is not wrong. I factored out a common factor. What's the problem, though? It's not the greatest common factor. 5 is a common factor, but it's not the greatest common factor. But let me show you how you can recover from this. Okay? So here's what you want to do. Every time you do one of these, if you're doing it mentally, if you're not making the lists, you need to do this. Can I get everybody to look up here for a second? You need to do this if you're doing it mentally. Mentally is much faster, but you got to do one quick check before you finalize, because you could make this mistake really easily. Look at what I've got left in here and ask yourself, is there anything else that I can divide a 10 and a 4 and an 8 by? Is there a common factor for those? There is a common factor for those. If you ever have a common factor left over inside, I can divide all of these things by 2. That means that this was not the biggest common factor. I need to go back and find something bigger. Okay? I did not do this check here, but do the check here for me. 3 and 4 and 1. Is there a common factor for 3, 4, and 1 other than 1? No. Then this one is done. We got the greatest common factor because there is no common factor left in here. But this one is not. So then I would say, nope, that's not right. Let's go for 10 instead, and the correct factoring would be 5v squared minus 2v minus 4. All right, why don't you guys try those last couple out, and then I'm going to come around and give you your assignment, and we've got a good chunk of time again to work on that. I'm hopeful to see a lot of completion again on Friday. Let me know if you've got questions. I can walk you through some of these. Again, if you can do these mentally, you do not have to write out the factor pairs, but sometimes when the numbers get a little bit bigger, it's helpful. So whatever helps you. And if your mental math is not that strong, if you write out these factor pairs like this, you will get better at doing it mentally. You'll get to the point where you don't have to do this anymore. But writing this out is going to help you learn those math facts to make these go faster.